to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the isomerism. And in this case, we are going to look at isomerism in alkynes. Previously, we looked at the naming of alkynes and we looked at the different rules in naming. So today we are going to look at the isomers, how they form, and the different types of isomers in alkynes. So the isomerism, just like in alkenes, alkynes also exhibit isomerism. And since because they have a triple bond in their structure, they can exhibit two types of isomerism, just like in alkenes. So we have the two types of isomerism. We have positional isomerism and structural or branching isomerism. So positional isomers for alkynes constitutes isomers that have the same carbon and skeleton, the same carbon skeleton and the same triple bond, but differ from each other on the location of the triple bond. So basically what we do is change the position of the triple bond in the carbon-carbon chain. So for example, if you look at this example of pentyne, you can see where the triple bond is in carbon number 1. This triple bond was moved to carbon number 2. And so we move from pent 1 ion to pent 2 ion. So this is what we refer to as a positional isomer. Let's look at an example of hexyne. So this means it has 6 carbons. So we have a triple bond in the first carbon. Ensure you count the number of bonds bonding each carbon. So we can comfortably move this triple bond in this carbon. So when you move it there, we get now a carbon with a triple bond here. So 3. So when we draw the number of hydrogens, remember we have to count, ensure that they are enough. So this carbon, we're not going to add any hydrogen, and also this carbon. So the hydrogens are going to be in this carbon. So since the first compound was Xan1 ion, this becomes X2 ion because the triple bond is in carbon number 2. So we can also move this triple bond to carbon number 3. So our new compound becomes, so we draw the 6 carbons. So we place the triple bond at carbon number 3. So this has an hydrogen, nitrogen, and hydrogen, hydrogen, hydrogen. We're not going to add any hydrogen in this carbon, nor in this carbon. Hydrogen, 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 and hydrogen. So this becomes X3 ion. So you see how we moved the triple bond to carbon number 2 and carbon number 3. If we do decide to move this triple bond here, we'll be repeating ourselves because it will still look like Xan 2 ion. So this tells us for the Xan 1 ion, it has two positional isomers, that is Xan 2 ion and Xan 3 ion. So we look at also heptane 1 ion. This has 7 carbons. So the triple bond is in the first carbon. So we put the hydrogens. Ensure you count the number of bonds. Should be 4, bonding each carbon atom. So we can move this triple bond to carbon number 2. That becomes, so we have moved it here, the triple bond. So we put the hydrogens in the last carbon. This carbon is full, this carbon is full, so hydrogen here. So this becomes ept2 ine. So we can also still move this triple bond here to carbon number 3. So it's going to look like this. We put the hydrogens. This is full, so we come to this hydrogen, this carbon that is. So this becomes a 3 ine. So if we move this triple bond here, we'll just be repeating the same compound because you start counting from this direction. So this tells you that heptane 1 ine has also two positional isomers, that is heptane 2 ine and heptane 3 ine. So next, also we said that alkynes have structural isomers. So structural isomers is where you change the structure of the isomer. It has the same molecular formula, but the different way of drawing the structure. So for example, we'll start with pentyne with 5 carbons. This is not supposed to be there. Let's put hydrogen, triple bond, hydrogen, this is full, hydrogen here, hydrogen, 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 hydrogen. So we can move this CH3 at the end to this carbon. Remember, we can't move it in this carbon because it's already full, it has 4 bonds. So we can only move it here. So it turns to be 4 carbon atoms. And then remember, we have moved it here. So CH3, and then the double bond is in the first carbon. So hydrogen, the other one is full, so it becomes like that. So this becomes 3 methyl but 1 ine. So there is no other because you can't move this CH3 again to any other position. There is no position left. Then we go to heptine. So this has 7. So we have a triple bond at the first carbon. So we put the hydrogens. So we can move this CH3. We can start moving it here. So it becomes 6 carbons. And we moved, there's a triple bond here. So we moved it in this carbon CH3. So we put the hydrogens. So this becomes 3 methyl pent 1 ine. So we can also move this CH3, still the same carbon on the top. So we end up having 5 carbons with a triple bond at the first carbon. And then on the third carbon, we have a CH3 and another CH3. And then there's an hydrogen, 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 and hydrogen. This becomes 3 di. There's a di methyl pent. This was supposed to be X, not pent, X. So pent 1 ine. So this can move this way, or we can have another isomer where instead of putting this H in carbon number 3, we put it in carbon number 4. If we put it in carbon number 4, we will have something like this. If we move it here, CH3, and the previous one was here, CH3. This is where the triple bond is. So it becomes like that. So the same isomer can be broken in two ways. So this becomes 3,4 dimethyl pent 1-ine. So we can't move beyond there. Those are the isomers of heptine. So you have seen you can have several isomers, positional isomers, and you can also have several structural isomers from the same compound. As you have seen in heptine, we had two positional isomers, and then you can see we have three structural isomers. That tells us that heptine can form five isomers and so on. So also other compounds, that is octine and nonine, can form positional isomers and also structural isomers. Sometimes you can be specified in the questions, like you are asked, you can be told specifically to write or to draw the structural isomers or to show the positional isomers. So, and other cases, we're just told to write all the possible isomers of a specific alkyne. So you can be able to mix them or you draw the specific ones that you want from the group. So that's how you show isomers in alkynes. So for the next lesson, we are going to be looking at the preparation of alkynes and how they are done in the laboratory. So see you in the next lesson.